Right, so we're going to look at the process for converting recurring decimals into fractions. They often ask this sort of question. You'll see the two questions I've got here. Write 0.72 recurring as a fraction in its lowest terms, and write 0.712 recurring where only the 1 and the 2 are recurring. This is the sort of question you get. You do get easier ones and harder ones, but let's work with these two. And you'll see that I've come up with a 4-step process. Some of the steps are very easy. We've got write our fraction as f equals. That's quite straightforward. The second step is we multiply by 10, and we keep multiplying by 10 until two lines in our working have the same decimal part. We'll see what that means in a minute. We then subtract those two lines and we divide to get f equals again, and we cancel to make sure it's in its lowest terms. So let's apply that process to the first question. Okay, right, so the first thing we need to do, step 1, it says write as f equals. So let's do that. Now I'm actually going to not use the recurring notation, but I'm going to sort of start writing it out. 0.7272 ... Okay, now what does it ask me to do? It asks me to keep multiplying by 10 until two lines have the same decimal part. Let's see what that means in practice. Well, if I multiply by 10 on the left-hand side, I get 10f. And if I multiply by 10 on the right-hand side, the decimal point moves one space, and I get 7.272727. And remember that the whole thing keeps recurring, so actually there are an infinite number of decimal places there. I'm just showing the first 4 or so. If I multiply by 10 again, I get 100f on the left, and I get 72.7272, etc. And you'll see what I mean by two lines having the same decimal part. Look, the first line and the third line there both have the same figures after the decimal point. And those are the two lines we're going to use. So in fact, I'm going to cross out the line that we don't need. Step 3 says subtract those two lines. So I'm going to I'm going to subtract here this way, okay? And the reason I'm doing it that way is so that I get the big number minus the little number. So I get 100f minus f is equal to 72.727272 minus 0.727272. Okay, and simplifying that, 100f minus f is 99f, and that equals, well, when I subtract the 0.72 recurring from the 72.72 recurring, the decimals disappear. And that was the whole point of doing that, really. So I'm left with only whole numbers, or if you like, integers. What does it say to do next? It says divide to get f equals and cancel if necessary. So I divide both sides by 99. Why do I do that? Because the 99s cancel on the left-hand side. That's my green cancelling pen. And I get f equals 72 over 99. And now all I need to do is do some more cancelling to simplify that fraction. And f is 72 over 99. Well, 9 goes into 72 8 times, and 9 goes into 99 11 times. And so I get f equals 8/11. And now, moving on to question 2. It's a slightly different recurring fraction, but the principle is the same. So, first of all, I'm going to write it as f equals. So I'm going to get f equals 0.7. Now it's the 1, 2 that recurs. So I'm going to write this as 0.71212, etc. ... in other words. Step 2, that's the multiplying by 10 until I get 2 bits with the same decimal in them. So multiply by 10, I get 10f is equal to 7.1212 recurring. Now you'll see that the decimal point has just moved one place to the right, basically. And if I multiply by 10 again, I get 100f. And that's 71.2121 recurring. Now let's just check these right-hand sides here. The decimal points on the right-hand sides. The first one is 71212. The next one is 1212. The next one is 2121. So none of these are the same yet. So I need to keep multiplying by 10. So multiply by 10 again and I get 1000f. And on the right hand side, moving the decimal point one more time, I get 712 point. Well, now it does start 1, 2, 1, 2 and keeps going. And you can see that the second line and the fourth line have the same decimal part. So let's actually get rid of the two lines we don't want by crossing them out so we're not confused into using them, and proceed to step 3. Subtract the two lines I'm left with. Okay, so as before, let's do a big subtraction this way. And again, I've done it that way to make sure that I've got the big number minus the small number. So I get 1000f minus 10f on the left. And I've got 712.1212 recurring minus this time 7.1212 recurring. Do the actual subtraction and I get 1000 minus 10 is 990f. And on the right hand side, yes, the decimal points cancel each other out when I subtract, but I do have to do a bit more subtraction. I've got 712 minus 7, which is 705. And now step 4. Divide to get f equals and cancel. So let's do my dividing. Divide by 990 on both sides. And on the left hand side, the point of doing that is that the 990s cancel. So I get left with f equals 705 over 990. Now, I don't know how your times tables are or your cancelling skills are, but it's pretty clear that 5 goes into both of those because one ends in a 5 and one ends in a 0. So if we divide the top by 5, we actually get 141. And if we divide the bottom by 5, we get 198. And you may spot that both of those divide by 3. So I'm going to keep cancelling. 141 divides by 3 to give me 47. And 198 divides by 3 to give me 66. Now I happen to know that 47 is a prime number, so I'm not going to be able to cancel any further. And my recurring decimal turns out to be equal to 47/66. You can follow this process for any recurring decimal, and it should work.